But do you really understand what potential means? We have all studied this term multiple times, but do we truly appreciate what it is? This word and its usage is almost second nature to us, but do we truly understand it? Let me ask you a question. You are standing on top of a tower with a ball in your hand, and you drop the ball to the ground. What caused the ball to fall down to the ground? Is it A. The height difference between the building and the ground, or B. The force of gravity acting on the ball, making it accelerate towards the ground? If you chose either of the two, then well, you're right. Both A and B make sense. But think about it. Which one of the two is a stronger, more complete reason? I'm sure you would agree that it's B, because stating the force of gravity as the reason makes it clear what pulls the ball to the ground, whereas the height difference doesn't explain the whole story. Now, let me ask you another question. Consider an electric circuit with a battery and a load. After the switch is closed, we observe that current flows in the wire. What caused the current to flow in the wire? Is it A. A potential difference across the load, or B. The electric field in the wire, which was quote unquote pushing the electrons in the wire in a specific direction? Well, again, both the answers make sense, but after analyzing the previous question, it is clear that stating the electric field as the reason tells us precisely what drives the charges in the wire, whereas simply using the word potential difference is a shallower explanation on its own. So then, the natural question arises, why do we use the word potential difference? Let us answer this why question, followed by how potential difference is defined, and then we shall use our new perspective to analyze another interesting question. To motivate the origins of the word potential difference, we must first understand a special class of forces called conservative forces. These are time dependent forces which only vary, if at all, with space, and they obey the property that the work done by them on moving an object between 2 points is path independent. Consider there to exist a conservative force in a region of space and an object situated at a point P. As the object is moved to different points in space, we can note down the work done by the conservative force on the object. Say, moving it to A takes 5 joules of work. Since this work does not depend on the path taken to reach A, we can associate the point A with this number 5 joules. Similarly, for the other points. In this process, we have treated the point P as a reference, and conventionally we assign it the number 0 joules. Note that the important thing in this argument is that every point in space can be associated with a number because of the path independent nature of the force. This number that we associate with every point in the region of influence of this conservative force for a given object is called the potential energy of that object when situated at that point. We can also calculate the work done in moving the object between 2 points by simply subtracting the potential energies. To be precise, there is a negative sign in the definition of potential energy. It is intuitive because, for instance, if we consider the potential energy of a test positive charge in a region of space where the conservative force due to a source positive charge acts, if the test charge is closer to the source charge, we would expect the energy of the system to be higher. A few more terms. Electric potential is just the electric potential energy per unit charge, and the electric potential difference is the difference in electric potential. Very simple. Now that we clearly understand what potential difference means, let us move on to the interesting question I promised earlier in this video, which is on how charges flow in an electric circuit. Let me ask you this after your newfound understanding of electric potential. To analyze the flow of charge in a circuit, should we analyze the potential differences or the electric fields? Well, it would be clear to you now that since potential difference is just a definition that we make by the virtue of existence of an electric field, it is the electric fields which are the main players in the circuit, and potential difference is just defined based on those electric fields. So then the question follows, what creates the electric field inside the wire in a complete circuit? One may think that it is the battery alone which is responsible for this. But that can't be the case, because if it were, a bulb would glow brighter when placed closer to the battery. This is not observed and hence not the case. So, there is something else which is responsible for the electric field, and it turns out to be, drumroll please, surface charges on the surface of the wire in the circuit. Here's an illustration. When the battery is connected to the rest of the circuit, charges are established on the surface of the wires. There is an accumulation of positive charges and negative charges on the surface of the wire as is visible in the diagram. Of course, only stating charges isn't enough. It is the gradient of these charges which really contributes to a net electric field at every point inside the wire. This also clarifies the common misconception that electrons move in a circuit because of mutual repulsion, because they quote unquote push each other. This is not the case. Electrons undergo Brownian motion in the wire, and an electron undergoes a net drift in one direction despite collisions with the positive cores situated in the metal lattice due to the net electric field that acts on them created by the surface charges and the battery. Voila! Now you understand that potential difference is just a term that we define to indicate the presence of an electric field in a region and mathematically describe it. It is considered more understandable and simpler to point out the potential at every point in a circuit with respect to some reference rather than modeling the entire electric field in the circuit, which is why defining potential as a quantity is useful in the first place. You now also understand what really causes the net drift of the sea of electrons in the wire in a closed electric circuit, which is the net field contributed by the surface charges and the field due to the battery. Hope all of this is clear, and if there is any confusion or if you want to know more, you can reach out to me. Thank you for watching.